The magnetic field in the cylindrical region is shown in the figure and it is increasing at a rate of 20 millitesla per second. So we have dB by dt, that is the rate of change of magnetic field is 20 millitesla per second. Each side of the square loop has a length of 1 centimeter. Let's say A is equal to 1 centimeter or 0.01 meter, and the resistance of each side is 4 ohm. Now we have to calculate the current in the wire AD in different cases. The first case is that when switch S1 is closed and switch S2 is open. Switch S2 is open, so therefore there will be no current in the loop ABCD because the circuit is open. So we have to calculate the current in circuit S1. So before that we have to calculate the EMF that is induced in that loop. So EMF is given by minus of d phi by dt. Taking only magnitude, we have d by dt of magnetic field into area. So it will be dB by dt into area of the loop. dB by dt is given by 20 into 10 to the power minus 3 Tesla per second, and the area of the loop is a square because it is a square. So a square, which can be written as 0.01 into 0.01. So EMF comes out to be 2 into 10 to the power minus 6 volts. Now the current in the loop can be easily calculated by Ohm's law, which is I is equals to E by R. We have EMF as 2 into 10 to the power minus 6, and resistance of the loop will be 4 times of the resistance of the each side of the loop, that is again 4. So on solving we get the current as 1.25 into 10 to the power minus 7 ampere. That is our answer. Again note that the resistance of this complete loop will be 4 times of the resistance of this side, this side, this side and this side, which are equal. So 4 times of resistance of each side, that is again 4 ohm, we have 16 ohm. Now to calculate the direction in this loop or in this wire AD, what we'll be doing is, we have the magnetic field inside the page, that is denoted by X, and it is increasing. So the current in this loop will be induced such that it can reduce the effect of magnetic field. So if the current in the loop, let's say this is my loop, if the current in the loop is in counterclockwise direction, then the magnetic field will be produced by this current such that the effect of the magnetic field that is applied will be reduced. And of course, since the magnetic field is increasing, the current will flow in counterclockwise direction. So if I'll name it as E, F, A and D, then the current is flowing in direction AD. So AD is my direction. In second case, switch S1 is open but S2 is closed. Now again, this S1 open now and S2 is closed. Now clearly that the loop is having the same dimension, the value of dB by dt is same. So the EMF again we are getting over here will be same as we obtained in the first part, that is 2 into 10 to the power minus 6 volt, and again the current will be same, that is 1.25 into 10 to the power minus 7 ampere, with the only difference in the direction, because again in this loop the direction will be in counterclockwise direction. So I'll make the loop and name it as D, C, A and B. Then the current is in counterclockwise direction, so the current is flowing from D to A. So just the direction will be switched and current will be flowing from D to A. That is the answer. In C part, both S1 and S2 are open, so obviously the circuit is open, there will be no EMF induced and hence there will be no current. So the current in AD will be 0. And in D part, when S1 and S2 are both closed, then of course due to S1 the current will be flowing in the direction A to D as we calculated in the first part, and current due to switch S2 will be in the direction D to A and of the same magnitude. So whatever the problem is, the net current flowing through D to A or A to D will be zero, because the two effect is nullifying each other. So again the current in the way A D will be equal to 0.